Hello and welcome back. So today is part 9 of building an AI computer improviser in Max. And today we're going to actually build our first musical behavior. So it will react to the live input, use some of the analysis that we've done to interact musically. The final improviser will have a ton of these behaviors, and the combination of them will cause a sort of interactivity that is varied. Great. So let's start that up. So let's make a new behaviors subpatcher. And we'll do a pretty straightforward behavior just to sort of give the idea today. We're going to do something that will try to match what it hears using the MFCCs and chroma when it hears an onset. And when there is not an onset, but it's passing, but there's sort of a certain loudness threshold that's being passed, a decibel level that's being passed, it will continually put out grains that will match. So it's essentially sort of a matching behavior. It's trying to kind of follow you and trace what you're doing. So I've loaded in a 4-minute corpus, which is just a solo fretless guitar improvisation. You can hear it's got a lot of, or see here, it's got a lot of slices, over 2,000 slices. Got all the muted attacks there, which sound kind of nice. So yeah, a ton of slices, and then the grains, half-second grains. So I'm gonna need chroma as well, so let's go ahead and do the chroma analysis. And although all the GUI freezes while we're doing the analysis, it should work in such a way where there wouldn't be audio dropouts, ideally, though we should probably stress test that. Great, and now chroma grains. Great. Great, so we have all of our analyses that we're going to use today complete. One thing I'd like to add that we don't have already is loudness here. So this could be done in a lot of different ways, of course, but let's just use the fluid object. So fluid.loudness, and what it will give, I believe, is decibel level plus peak. And let's smooth out the data a bit using that. And we are not actually going to need to write it to a buffer, at least not at this stage, because we're not going to do loudness matching. So I'm going to clean up this window at a certain point. Okay, but let's just make sure that this is working. Do I have my ADC coming in? I do. So let me see. Oh, of course, I need to attach these two. There we go. Okay, so the so we can essentially use either of these. Let me get the actual information of what they are. Oh, that's annoying. There's an autoplay on this. Okay, so fluid loudness reports to loudness and true peak in decibels. So I think actually for now, we can just do a send loudness so that we have that information, because I know we're going to need to rely upon that later. Okay, so let's build our behavior. Okay, so first I'm going to want an on-off switch for everything, and I'm going to want to have that initialization button to sort of always be able to turn it off, and I want it to always be off when I launch a patch. So I'll do that with a toggle here. Actually here, I want to be able to just bang it out and have it turn off. So just like so. First, let's do the attack matching on offset detection. So we already have that with onset. Is it onset or onset? It's onset, yeah. So that can just go right in there. Great. Now, what I want this to do is that if the incoming sound has a clear monophonic pitch, I want it to use the chroma matching. But if it's noisier, I want it to use the MFCC matching. So here we can do this with a gate with two possible outlets. And if we receive our pitch data here, I'm going to, unpack the pitch data like so. And let's see, let me make sure I have the receive object correct. So in my audio input, we simply need it, we don't have the send here. So let's do send pitch data. Go from there. And now we have our pitch data. Ooh, see, that's confidence and the pitch. So this will be one of the points that I will gate using my on-off initialization there. So if it's off, I'm not going to be sending the pitch data through. I'll just be cutting off that calculation early on in the process. So we don't actually need the precise pitch. All we need is all we want is the confidence. I'll leave it on for now. So, ooh, I find that when it's lower in pitch, it's less confident always. Ooh, shh, Let's say greater than 0.4. We'll count that as clearly pitched. So put that in there. So we could sort of make that a little bit more interesting by also scaling this by by how much low frequency content there is, or what the fundamental is, because it seems like lower pitched noises, the confidence is much lower. So in any case, greater than 0.4. And then, so that'll give a 0 or a 1. So in order to use the gate how we want, we'll add 1 to that. And so now it'll be 1 and 2. So 1 will go out to our MFCCs. Oh, sorry, it should go, no, that's correct. 1 should go out to our MFCC matching, and 2 should go out to our chroma matching. So we'll put that through there. So right now this gate should be open. Yeah. And if we go, ooh, then that one's open. Great. One thing that I've added to these analysis objects are just a couple of receive objects. So a live match, so it goes directly to our live matching button essentially here, message, and then a make note one. So I could sort of just force out either one of the grains or one of the slices there. And so that'll be useful a little later. I probably won't use that today, but today we will definitely be using this one. Okay, great. So I want to actually send to MFCC, or no, not MFCC grain, but MFCC slices live match. So let's go send MFCC slices underscore live match. Kind of, yeah, okay, that looks good. Just to make sure that I have not made some weird error there, let's just go ahead and bang that out. Ooh, great. Those slices are very short. Great, so if it's coming out of 1, it should go here. Great, and then for this one, we'll want chroma slices live match. Ooh, cool. So it's kind of a neat effect already. For now, I'm just going to turn this off so that we, oh, so that this can also go, hold on, select 0, 0. There's probably a more elegant way of doing this, but just for now, let's go ahead and do that. Okay, there, now it's gated. Okay, good. One thing that we might want to do here as well is we don't need to send the gate constant information, so we can put a change object there. And again, sort of cut off that calculation and that process earlier. Okay, so we have our matching, so that's already kind of interesting. I feel like for this, it could be interesting to maybe, actually, let's leave that for now. Let's build the second part, and then we can decide if we want to randomize the panning or randomize if things are played forward or reverse and things like this. So now let's build out the second part of it, which is the sending constant grains if there's a certain sort of loudness threshold that's being met. All right, so let me just clean that up like that. So for that, we're going to want to see if we're not getting onsets. The sensitivity of the onset's also very high. I'm going to turn it down a little bit here. Yeah, 0.1 is very low. So let's put it to 0.3. Ba, ba, da. That's good. Could maybe even a little less sensitive, but that'll work. Okay, so now I want it to be so that if it doesn't get any onset for half a second, then it starts sending continuously every quarter of a second a request for a matching grain. Again, MFCC grains matching if it's below a certain pitch confidence threshold, and if it's above, chroma slice matching, or not slice matching, chroma grains matching. So to do that, let's put in a clocker, and I know I want it to be half a second, so I'm just going to do it like that. And here, so now select 0 and select 500. So a 0, when it gets a new attack, it's going to say close the gate. And if it gets to 500, so if it gets to half a second, opens the gate and starts sending these matching messages. So for this, I do 0 because I'm going to close the gate with it, 1 because I'm going to open a gate with it. Gate there. Good. If anybody watching this ever has suggestions on how to do any of this stuff more efficiently or has ideas, I'm really interested to hear them. But for now, the behaviors are kind of very sort of basic logic. Okay, so that opens and closes the gate. So we'll be sending our message through there if it's over half a second without a new onset. Let's get our loudness data. Or did I just say our loudness? Hold on. I think so. I want to do it similarly to here. Okay, great. It's coming through. Ooh. Ooh. Okay, great. Let's use this one. And let's just do let's smooth it out a little bit. So ZL stream 8 ZL or hold on. Can you do it with the space? You can, okay. ZL median. Great. Do. Okay. Perfect. All right, so we're averaging, or we're getting the median of the last 8. So there'll be a small delay on it, but that should actually be more than fine because of just sort of because of the musical effect that we're going for here, where it's like on a sustain, trying to match things in. So it doesn't need to have a precise attack or something like that. All right, so we're going to gate our loudness data as well using that same initialization on-off switch there. Let me just put that on-off. Great. Okay, so from here, if it's greater than negative 45, let's say, then that's enough for it to be some sound. All right, I have to open it up. Ooh, ooh, ooh. That seems good. It could probably even be a little higher, but that will work. Again, it's going to be evaluating this over and over and over. So let's do change here. And now we can use this. So this will be a 1 or a 0. So we can just use this to turn on and off a metro. And because our grain size is 500, then let's do 250 milliseconds for the interval, so that the next grain will be begin at the peak of the previous one. We'll get some sort of something that sounds pretty smooth. All right, so that should work. Let's just test that to be sure. Ooh, great. And if we're quiet, nothing. But if we make noise, ooh, it turns on. Great. Okay, so I'll turn that off. We'll also turn that off manually like so, in case it turns off. If it turns off before, while I'm still making noise, then it will just keep running. Yeah, because it's gated up here, so it won't be sending data through that will give it the less than 45. It'll just stop, and so that will remain on otherwise. Okay, so now I believe this is where, from here, we can just put this. So that's our gated metro there. So now after 500 milliseconds, we'll get those attacks going through there. So we're gonna make the messages a little bit more interesting eventually, but for now, let's just do simply mfcc grain underscore match. Ooh, not Mitch. Match. Well, I know I'm gonna want to send data about how to pan it and how loud it should be and whatnot. So we can go ahead and do this with a trigger bang bang already. So we want to send all that panning and other information out of the first one, and then the second will be to call the actual note. Oh, and of course, we want it to be either MFCC or chroma grain based on the confidence. So we can use this same gate over here. Yep. To open and close that. So if it's confident, it will come out the right inlet. If it's not confident about what the pitch is, come out the left inlet. So left inlet for the MFCCs, right inlet for chroma grains. So chroma grain match. Let me just make sure I have these messages correct. It looks like that one I don't. It could be chroma grains. Yeah, it's chroma grains. MFCC grain. Okay, so I should rename that MFCC grains, but I'm going to fix that later because I don't want to have to redo the anything. Live match, not just match, live match. Livre match, live match. Live match. Great. Great. Okay, so those will go like that. And then, so already we can kind of test this out, and it should more or less work, and then we're going to refine it. I'm going to want this gate, of course, to go into here, and then I think I have everything connected. So it should match my attacks, and then if I'm doing sustained sounds, it should come in with grains. Ooh, oh, I have this awful bug. There we go. Ba, da, da, Great. So it works. I can think of immediately ways to make it more musical. Have the grains be softer, sort of they could have an envelope follower applied to them. Also, we could have it so that the onsets are an appropriate time to link up with our sort of sustain portion of the grains that play back. For today, let's complete this behavior by working on having sort of envelope following and randomizing the pans of these of the grain portion, and we'll just leave the onsets be for today. Or we'll see how long it'll take. So from our last day, we had this note message object that we made, mfcc grain. So if we do that, then we can send it gain, speed, window, pan, direction, and extension. So like how long the grain should be. Or adding additional length to the grain. So let me just keep that open. It'll be a minute until I memorize what these are. Move that over. Let's randomly choose if it's going to be played in forward or reverse. So we can just use decide for that. It'll send a 0 or a 1. And then if we just add 1 to it, because 1 moves forward, 2 makes it go play in reverse. Oops. Then we can get that. So decide. Great. So that will be there. And let's do that for both chroma and MFCCs. Chroma grains. Great, so now half of the objects, or half of the samples played back as grains should be in reverse. Let's go ahead and test that. Ba, 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 ba. Okay, why is it not working? Getting our onsets. Da. There we go. Ba. Great, so we can hear some of them are in reverse there. We should figure out what caused that sort of delay in terms of, sorry, I have too many windows open here. What caused that delay in terms of it not sort of immediately beginning when I turned it on and off. What that would be. Oh, it waited for a change between the thresholds here. So let's actually, oh shoot. We can just get rid of that, and that should solve our problem. Ba, ba. Cool, all right, let's turn it back off again. Let's randomize the panning. So for that, we need 0 is hard left, 1 is hard right. So if we just simply do random 100, and then we divide that by 100, we'll get a random value between 0 and 1. And that can be sent into our pan, which is a third from right there. Great, so that again, like so, and we'll want to do it for this one as well. Okay, so we've randomized our panning. We don't need to play that back. I want the grains to overlap in a smoother way, so we're going to change our window shape to be more sinusoidal. And so basically at 0, it's perfectly sinusoidal, and at 1, it's perfectly trapezoidal. Though if you get a full 1, it literally has no window at all. It's just full. So you never want to go beyond like 0.99. But in any case, to make a sort of Hamming-like window, I'm going to give the window shape 0.4. there. So that can be banged out every time, or we could also bang that out when we just turn it on once, because we know it's going to be like that the whole time for this behavior. Though when we start layering behaviors, that's when that becomes important. Okay, great. So now we have a smoother window, randomized pan, and now let's do the scaling for the gain. So let's scale it between 0.5 and 1, and our gain should go in the first inlet there. So I'm going to use the scale object from the decibels. So let's scale between -40 as a float and 0 as a float to be actually 0.5 is maybe too much. So let's do 0.6 and 1. So a lot of the messages will be around the 0.7, 0.75 range. And for this, because the scale object will continue beyond the bounds, if we get like, I don't know, -60 or whatever, that is sort of just good practice in my book to clip it. So if we take our, let's take our smoothed loudness and scale it there. And that can be sent to continuously to the loudness of our note messages. Though we actually, hold on. If it's continuous, then that could get in the way of layering behaviors later down the road. So let's actually be a little more careful with that. Let's store that in a float box and then bang that float out as needed. Okay, so that should do it. Let's test this out and see how it sounds. Ba ba. Shh. All right, kind of interesting. I think it could be more interesting to sort of fill out the continuous sound a little more, and I'm finding that this I like it to be a little more sensitive. So let's compress this, scale -10. Nice. Okay, so that's a first behavior there. And so we could kind of imagine from here making a whole range of different behaviors so that your sort of AI musician reacts in different ways. So, and then there's a question of course, at what point is a behavior turned on? At what point is it turned off? How to give, provide a sense of, when you say you want to end a performance, if you're in the beginning, if you're at the start, sort of these things concerning the overall form are going to be big questions. But for the next few videos, we'll probably just be building out a bunch of interesting behaviors and seeing how we can combine them to give the sense of interesting interactivity. This might also give you a sense of what you might want to explore in terms of how you train the corpus and the relationship between what the corpus is and how you train it, and how that influences what kind of music that you make. So most of the music I make is microtonal, maybe more on the experimental side, free improvisation side, and so that's where my mind goes. If you wanted to create something that is more in some sort of like dance music tradition, something more rhythmic, you would maybe have very different behaviors than what I just showed today. Though I hope to sort of bridge that gap a little bit as we go forward. And also the idea of it sensing, a scale that it's being performed in, or some sense of tonal center, I think could be interesting to develop into this patch. But it's in the end, it is kind of the way it's set up, it is sort of best suited, I think, for a kind of experimental free improv style or genre, if you will. Okay, so that's going to complete what we are going to do today for the video. I would like to say that I'll put again the updated patch for today under a new Part 9 folder on the GitHub for TSC, so that you can have this up to date. And before I upload it, I'll probably clean up a couple things, like I'll probably clean up this subpatcher, and maybe make some of the naming conventions be consistent. Okay, so with that, I'm done for today, with the exception of saying that comments on different behaviors to build, or even sending in some behaviors, would be really fun if people are this far along and actually kind of building along with this at all. I'd love to see what people come up with. Yeah, so please message me. Please comment on the video with that. Okay, see you all soon.